Hello, YouTube. Today we are going to try to build the power transformer whose design we calculated in our previous video. Power transformers design considerations. These are the specs. It is an isolation transformer capable of delivering approximately 200 VA. I think we have everything we need. The iron core, a spool of enameled copper wire, our bobbin, a piece of craft paper, some brackets and some bolts and nuts to keep everything in place. Before we proceed, it is never too much to stress once more that this is not a step-by-step do-it-yourself video. Just nerd entertainment. And to build a device like this you need to be a qualified professional or work under the supervision of one. So please do not try this at home or anywhere else for that matter. Since I do not have any kind of machine to wind the wire around the bobbin, this is how I do it. I try to wind the wire as tight as possible. After each layer I stick a piece of masking tape with the number of turns already wound. This is convenient if you have to interrupt your work for some reason and resume it later. Then I wrap each layer with craft paper or masking tape, taking care to leave all the overlappings facing out of the transformer. Also, no connections or mendings of wires should be in the span of the window area. Now I have managed to wind the primary and I have covered it with a piece of craft paper all around the winding, and fastened it with masking tape to protect it and to avoid any physical contact with the secondary that I am about to wind on top of the primary. Because this is an isolation transformer, the most important thing here is that the primary and the secondary be completely isolated and absolutely no galvanic contact be made between the two. As you can see, I keep constantly adjusting the wire to avoid unnecessary gaps between each turn, which would reduce the number of turns per layer. And I also keep the turns from crossing one over another, which would unnecessarily compress the enamel insulation at the crossing point, causing possible short circuits. By the way, I never reuse wire from another transformer, the reason being that you can never be sure about its condition, especially regarding the enamel insulation. A shorted turn makes any power transformer useless. This is how I count the turns. I take a plastic stick with a sharp point like this spudger. By the way, I never use anything metallic with enameled wire because I do not want to damage the thin insulation. I then run the tip of the spudger over every loop of wire and count 1, 2, 3, 4, etc. Just like that. This does not work, of course, with fine wire. Only with relatively thick wire like this one. So here is the bobbin completely wound with the primary and the secondary, and it weighs, as you can see, 705 grams, quite close to the predicted 700 grams for the wire alone. We are now going to check the primary and the secondary for continuity. Primary is okay. Secondary, too. And now the moment of truth. Let us see if there is any continuity between primary and secondary. You can see that there is no continuity. Therefore, the bobbin has passed the test for an isolation transformer. It is important that you test all the windings for insulation and continuity before installing the core. If something is wrong, you just rewind the problematic winding. Otherwise you will have to do the tedious and time-consuming task of disassembling and reassembling the core again. We have finally got to the fun part of it, which is installing the E and the I laminations of the EI core. I have to pay attention not to cross over the legs of the E's like that. I am not showing how to install the I laminations, but it is clearly obvious that each one goes in the gap left by two consecutive E's. All the laminations are now installed. The last ones I had to hammer in so that they form a very tight core. Then I hammer all over the sides of the assembly against a flat surface so that the laminations get nicely aligned with each other. Notice that the laminations get so snugly and tightly fit in the bobbin that they do not move even without the fastening screws. And now we install the brackets. Notice that the screws are wrapped with shrink tube so that they do not short the various laminations, defeating the purpose of the thin insulation layer deposited on their surface, which is to minimize the effect of the so-called eddy/focal currents. Now let us check the weight of this thing. It is about 3.48 kilos. That comprises about 2.7 kilograms of iron plus about 700 grams of copper, plus bolts, nuts, leads and sheets of paper. With everything now in place, we need to perform some tests to see if everything runs as planned. Because one is never sure how it will behave, one does not simply connect a freshly wound power transformer to the mains. Our general setup for testing comprises a variac for raising the primary voltage gradually while monitoring currents and voltages, a current limiter and various meters. But before we perform some measurements, let us review the simple model we established for a power transformer in the first video of this series. Power transformer is a simple circuit model. Our sub W is the resistance of the secondary wire reflected on the primary plus the primary wire resistance. L sub Lk is the leakage inductance of the secondary reflected on the primary plus the leakage inductance of the primary. Our sub C represents the core losses and L sub M the inescapable magnetizing field. Next we go to the open secondary test, in which we measure the secondary voltage and the primary idle current, which in this case will be equal to magnetizing current plus the core loss current. And there we have it. The voltage on the primary is 127 volts, and on the secondary is 127 volts also. Very nice. That indicates that the turn ratio is exactly 1:1. The magnetizing current plus the core loss current that comprise the idle current is 87 milliamperes, which is a very good figure. Since there is no current in the secondary and the idle current is much less than the nominal current, the effect of R sub W and L sub Lk can be neglected for this test. This test also indicates if there is a shorted turn in any of the windings. If that is the case, the current on the primary will be only limited by the resistance of the primary winding and will certainly be greater than the nominal current for which the transformer has been designed. Now it is time for the secondary short circuit test. The purpose here is to measure the voltage regulation. Using the variac we are supplying the primary a voltage which is enough to make the secondary exhibit as nominal current of 1.5 amps. We can see that we have 7.7 volts on the primary. Now the effect of R sub C and L sub M can be neglected, because the voltage on the primary is much less than the nominal voltage. That a 7.7 volt drop is very good indeed, giving us a 6% regulation, less than the 6.6% that we were expecting, considering the wire resistance alone. I am very satisfied with that. The final test is the temperature test. Since we chose paper as the insulating material for the various layers of wire, the temperature inside the transformer cannot go higher than 100 degrees Celsius. Here we have two 100-watt light bulbs that we are going to use as a dummy load. We have agreeable 24 to 25 degrees Celsius in our workshop. We have a 2-amp fuse in series with the primary in case anything goes wrong, and we have this temperature probe here next to the inner layers. And here we go. While the test is running, I will babysit this beast and keep an eye on the temperature rise, as well as look for any signs of premature failure. Well, this test has been running for more than 2 hours now, and the temperature seems to have stabilized between 73 and 74 degrees. It has not changed for the last half an hour or so. The transformer has not released any magic smoke so far, and the final temperature seems to be more than adequate for the insulation material we chose. So, I think we can call this a winner. There you have it. The transformer is pretty much in spec. It is not buzzing, it is not humming, and it is ready for immediate use. Thanks for watching. Have a good night and stay beautiful.